Welcome back, calculus learners. Today, I am going to introduce some series that we need to be familiar with.
These are the geometric series, the harmonic, and the p-series. As defined, the geometric series is the summation of a times r raised to n minus 1. N ranges from 1 to infinity. So this summation is equal to a plus a times r plus a r squared plus, of course, the next term would be ar cubed, and that will go up to infinity. So this geometric series is convergent. Remember, this is convergent if the absolute value of r, this one, is less than 1. And the geometric series is divergent if the absolute value of r is greater than or equal to 1. Now remember that if the series is convergent, you can identify its sum, and this is the formula: a divided by 1 minus r. A is the first term here. Next, we have the harmonic series. Harmonic series is divergent. And what is its structure? As defined, the harmonic series is the summation of 1 divided by n from 1 to infinity. So you can see here the sum as 1 plus 1/2 plus 1/3 plus 1/4 and so on. The third one is the p-series. What is a p-series? P-series is the summation of 1 divided by n raised to p, where n ranges from 1 to infinity. This p-series is convergent if p is greater than 1, and it is divergent if p is less than or equal to 1. So p here is the exponent. To summarize, we have the geometric series, which is the summation of ar raised to n minus 1, n ranges from 1 to infinity. And we have two cases for the geometric series. It can be convergent, and the geometric series can also be divergent. So in which case does this happen, that the geometric series is convergent? So this is convergent if the absolute value of r is less than 1, and this is divergent if the absolute value of r is greater than or equal to 1. We also have the harmonic series, and this is the summation of 1 divided by n ranges from 1 to infinity. So this is always divergent. So remember that the harmonic series is divergent. We also have the p-series. There are two cases. The first one is convergent. This happens when p is greater than 1, the exponent. So remember, for geometric series, you have to look for the base, which is r. For the case of p-series, you have to watch out for the value of p, which is the exponent in the denominator. And there are also cases when the p-series becomes divergent, and that happens if p is less than or equal to 1. So, in fact, if p is equal to 1, the p-series becomes a harmonic series. See? If p is 1, you will have 1 over n only. So that is going to be harmonic, and that is divergent. Remember the geometric series, it's the summation of a times r raised to n minus 1. N ranges from 1 to infinity. So this is geometric. All we have to do is to refer to the value of r. So for this case, r is greater than 1. It's 4/3 is greater than 1. So since r is greater than 1, we may say that the series is divergent. There you go. So that's for the first example. Let's take a look at the second example. It's actually having the structure of a p-series, and remember the p-series, it's the summation of 1 over n raised to p, where n ranges from 1 to infinity. So this is a p-series, and remember in the p-series, all you have to do is to look at the value of p. So for this case, p is equal to 3 and it is greater than 1. Hence, we may conclude that the series is convergent. To determine if the series is convergent or divergent, we have 4 items. I want you to share your answers in the comments below and tell me if you can easily determine if the series is divergent or convergent. Feel free to share your ideas, ask questions, and share your answers.